Welcome to Paresh video tutorial. In this tutorial I'm going to show you how to design a 4-bit magnitude comparator circuit using Multisim. As we all know, a 4-bit magnitude comparator has 8 input terminals and 3 output terminals. The output terminals each represent one of these conditions: A equal to B, A less than B, and A greater than B, where A and B are inputs. Okay, we are going to need these equations for each of the 3 conditions to design the circuit. Now let's start. First thing we need to do is place source and ground. The VCC and ground. Right. Then we go for switches. Basic switch SPDT. Okay. We're going to need 8 switches for each of the 8 terminals. Let's remove the labeling, show the labels. This is for A3. Okay. Let's flip it horizontally. Okay. Gives us 2 input terminals and 1 output terminal. Right. So copy, paste. We need 8 of these. 5, 6, 7, 8. Okay, 8. This is B3. This is A2. This is B2. A1, B1, A0, B0. Okay, let's connect the VCC. And ground. Let's give it black color. Okay. Right. Now we need to place a NOT gate for each of the terminals. Go to TTL 04. Alright. Remove the labels. Display schematic global setting and uncheck the boxes. Copy, paste, paste, keep on pasting. Done. Now connect these. Okay, now we are going to need 8 AND gates, and is 0 8, so the same. Copy and paste. Okay, let's connect it here and here. Let's move it a bit to the right. Okay, done. Similarly connect all of them. We connected it this way because here in this AND gate gives us the output A3-B3, that is for this one here. Similarly this gives us A3-B3-, and all of these give us outputs in the same way. Okay, now we need to place a NOR gate 0 2. Alright, I connected these two AND gates with the NOR gate. Now let's go to this equation. Right. Okay, let's do one thing. Copy, paste. Paste, paste. Right. Here we have the equation A0 B0 dash plus A0 dash B0, that is this AND gate gives us A0 dash B0 and this gives us A0 B0 dash. If we put it in a NOR gate, we get, as after simplification, we get A0 B0 plus A0 dash B0, that is our X0. Now to get similarly to get X3, X2, X1, we need to connect it in this way. Let's continue. Done. Okay, next we need to place AND gates. So TTL, sorry, we need to go for a 4 terminal AND gate, that is here. Okay, let's connect it. The 4 terminal AND gate is required because we are going to add, we are going to multiply x0, x1, x2 and x3, that is put x0, x1, x2 and x3 in the single 4 terminal AND gate. So we are going to connect each of these to the AND gate. Right, I will change these. This is x2, this is x1. Okay, this will give output a equal to b. Now we need to go for a less than b and a greater than b. So we'll need two terminal AND gates. Here, and 3 terminal AND gates, and 4 terminal AND gates. Okay, let's remove the labels. Done. Now copy and paste here. Now copy this and paste. Can copy this and paste. Okay, now we need to connect it here and this here. This AND terminal is for this expression, right, this expression x3a2-b2. This AND gate here gives us a2-b2, and this gives us a2b2-. Okay, if we connect it with another AND gate and this here x3, so that gives us x3a2-b2. If we connect this to x3, gives us x3a2b2-. Okay, now similarly here, this is for this expression x3 x2 a1-b1, these two x1, sorry, x3 and x2. Same way here, x3 and x2. And this one is for this expression x3 x2 x1 a0 dash b0. So this here goes to a0 dash b0, and these three are connected to x3 x2 and x1. Similarly here, this AND gate is for this expression. So now we need a 4-terminal AND OR gate. 4 OR. We need 2 of them actually. Okay. Copy and paste. Okay. Now we are going to add all the 4 terms. That is, first comes a3 dash b3, then x3 a2 dash b2, that is this, x3 x2 a1 dash b1, this, and x3 x2 x1 a0 dash b0, that's this. Now for the a greater than b, a3 b3 dash, so it goes here. Next x3 a2 b2 dash, next x3 x2 a1 b1 dash, okay. Last one x3 x2 x1 a0 dash b0 here. All done. The only thing left now is to connect probes. Indicator, probe, let's go for green. Okay. This is A less than B, copy, paste, and paste again, connect it, change the values. This is for A greater than B, and this is for A equal to B. Alright, done. Now we simulate. All of it is 1, so we have A equal to 15, B equal to 15, thus A equal to B. Now if I make A equal to 1 1 1 1, that is 15, and B equal to 1 1 1 0, that is 14, so A greater than B. Now we reverse it. A is 14, B is 15, so A is less than B. That's all for this tutorial. Thank you.